Here in the given problem, a metal wire is stressed under two different tensions and it is vibrated in its fundamental frequency. Beats are produced with tuning fork under the two conditions and same beat frequency of 5 beats per second is heard. In the condition of higher tension, the metal wire will vibrate with 5 unit higher frequency than tuning fork, and in case of lower tension, the metal wire will vibrate with 5 unit lower frequency than tuning fork. Applying the fundamental frequency formula for transverse wave in metal wire, we can get the desired result as asked in the given problem. In the problem shown here, a composite wire of two different material and same diameter is taken and a transverse wave is set up along the wire. Now in case of a continuous composite wire, the whole wire have common vibrational frequency. Let the steel wire vibrates in its pth harmonics and the aluminum wire vibrates in its qth harmonics. Applying the equal frequency criteria, we get P ratio Q is equal to 3:1. Now for lowest frequency of vibration, Q must be equal to 1. It means aluminum wire should vibrate in its fundamental frequency and its frequency value is calculated as 163 Hz. The total number of loops formed will be 1 plus 3 is equal to 4. Hence number of nodes formed except from the extremities nodes will be 3. In the problem shown here, the fundamental vibrational frequency of air within an open air tube from both sides is given. Its length of 48 cm is also given. The key point in this problem is that we have to apply yield correction, as when we calculate the fundamental frequency without yield correction, it comes different from the given fundamental frequency in the question. With yield correction, when we calculate the fundamental frequency and equate it to given fundamental frequency of 320 Hz, we get the diameter of the tube. In the problem shown here, a steel wire is hanged with a block of mass m, and firstly a longitudinal wave is set up along the steel wire and later a transverse wave is also set up along the wire. The speed of longitudinal wave depends upon the Young modulus of the steel, while that of transverse wave depends upon the tension produced in it. Because of the varying speed, the frequency of oscillation in both cases will also be different. Applying the required condition as given in the question, we can find the area of cross-section of the wire. In the problem shown here, when the block is completely submerged in water, the tension in the sonometer wire is reduced, hence the velocity of transverse wave is also reduced. Since in the second case also, the wire vibrates in same fundamental frequency, hence the wavelength of transverse wave setup is also reduced as the velocity is reduced in the second case. So the clamp must be reduced by 5 cm in this case. Equating the same fundamental frequency in both cases, we get the desired result.